In this module, we're going to learn about the different software development life cycles. So now that you kind of understand what is the backbone of programming languages, you know what a programmer is, how do you actually come up with the process of developing software? And so we're going to talk about these different types of things. There are a lot of different methodologies out there. We're only going to cover just a couple of them in today's section. I'm going to warn you, some people think that some are better than others, and quite honestly, they might be right, but we'll find out. So, according to Wikipedia, there are 6 main different types of software development life cycles. We're only going to cover 2 of them today. The software development life cycle is essentially a methodology to how to develop software. And as a beginner programmer, you probably won't really run into this right away, but as you start developing bigger and greater projects, you are going to need to be able to figure out what's the best process for doing this. And that's what these software development life cycles are for. It's really controversial. If you talk to somebody that thinks that agile is the way to go, then they're really going to be adamant about the way that the agile is the way to go. Others think that waterfall and V-models are the best way to go. And you never really know. Some think that it's continuous integration. And even within some of these, within the agile, there's so many different methodologies inside of agile that people subscribe. Some people think that Scrum is the best way to go. Others think that it's document-driven development or test-driven development. Really what the matter is what is the specific task you're trying to find, and then determine, is this software development lifecycle the best for that task? We're going to go over the 2 most common ones, at least in my experience: the waterfall/V model, and then agile. In the waterfall and V model, essentially is this downward trend of processes. Let me show you this graphic. You have these requirements, which then feed into a design, which then feed into the actual implementation, which you then verify, and then finally you have this maintenance. Well, requirements, that's essentially a set of statements that says the software shall do this. And these you kind of define, okay, this is what the software is supposed to do. Not necessarily how it accomplishes those things, but what is it supposed to do? How fast is it supposed to do those things? How accurate is those things supposed to be? Those are all types of requirements that you need to be able to do. Once you've kind of nailed those down, then you feed those things into the design, and you design how exactly does this software accomplish that? And granted, you haven't even done any writing of code at this point. You've just designed it. Oftentimes it's done using the unified markup language or modeling language, or UML, where you model out and you model out how the different interactions of these different types of functions and components of the software interact with each other, and how you do all that. Then finally, you get into the actual implementation of the software, and you actually write down in the code how it implements those requirements and then those design. After that's done, then you have a verification. You do some testing to make sure, does the actual implementation meet the requirements, and does it match the design that we laid out? And then finally, after it's been delivered, you maintain, maybe make some small changes to whatever the software is. You've identified some bugs, you go back and you fix those bugs, and you just kind of maintain that software. The V model is kind of a modified version of the waterfall, and it's broken up into 3 major sections. You've got the requirements and design, you've got the implementation, and then you've got the verification and validation. Let's look at this graphic. So the idea is that as you define these requirements in architecture and then your detailed design, you're also doing with a forward thinking of, how would I verify and validate these requirements in architecture? And then in this detailed design, how would you integrate or test these types of this design. And so it's kind of a forward thinking, and then you actually implement it, and then you do the same thing back, and you do this integration testing and this verification and validation, and check to see, does it actually meet and do that. So it's kind of almost a circular process here, but it's very much you go through each of these different stages, and then once you finally reach the end, you have a final product that you deliver that's in there. You don't necessarily repeat all of these steps. You just go through and you do them with an eye kind of forward and backward towards the future and past of the steps that's there. And so that's kind of why you have this little bit of a V looking type situation there. There's some really advantages to using the waterfall or V models. By the end, you have a very well-defined system that spans the entire intended operation. So when a customer comes to you and says, I need this, and this is what it needs to do, you have a well-defined system that you've given to them. And that's been very well done. You, at the end of the delivery, you have a fully working, completed product. It's ready to be delivered. That doesn't mean that it's bug free, or doesn't necessarily meet maybe some intended requirements that they wanted, but didn't realize that they wanted. But it is a fully working system based off of the requirements and the design that you've defined. When it's done correctly, this is the best process for a system that's like a single delivery, such as a spacecraft. I work in the space industry, and we use a version of the waterfall / V method to do a lot of our development. And everything's kind of centered around that. The fact that you go through these kind of stages of requirements, then design, and then implementation, then test and verification, and those types of things. And you have a final product, because once you put something into space, there's really no going back. You can make software updates potentially, but they cost time and they cost bandwidth of the radio. And those are all things that sometimes you just don't have. So you have to be very careful that when you deliver a software, it has to be ready to work on there. There are some disadvantages to using the waterfall and V models. It's not very flexible. Once you start progressing through the steps, it becomes really costly, and it impacts the overall system as you make changes to previous steps. So for example, if you're in implementation and you make changes to requirements, that's a big change. And you kind of need to be aware of that. Even further, if you start making changes to requirements and you've already implemented it and you started verifying it, you've got to go back through and go through that whole process all over again. So it's very costly, and it's not very flexible. It just takes a lot of time to do that. Feedback from the customer is also kind of interesting, because you don't really get feedback from the customer until after you've implemented and tested it. And so you really hope that after you've worked with them and you've had communication with them through the requirements and design, that what you implemented and then present to them is really what they want. You don't necessarily get that constant feedback from the customer like you might in other situations. Let's talk a little bit about agile and how that's a little bit different. So agile is actually kind of an encapsulating term. There's a lot of different types of agile methodologies out there. For example, there's the adaptive software development, extreme programming, there's lean startup, there's Kanban, there's Scrum, there's this and that and this and that. There's so many different types of agile, quote unquote, development that's out there. Test-driven development, documentation-driven development, just lots of stuff out there. The thing that has all agile developments have is these kind of three main components to them. First, they're iterative, meaning that each release and delivery of the software is done using kind of a cycle. So we went back through, if we looked back at that V, it was kind of just this one-time V. Well, what if we turned that into a circle and just kind of did that over and over and over again? In fact, let's look at this. This is actually the process for the Scrum process, right? And so you have this sprint where you kind of do multiple iterations of this, and even iterations upon iterations of this that's in there. So it's iterative. You're doing kind of the same amount of chunkable work over and over again. It's incremental. So the idea is that you take a release and you build upon previous releases. So release one might implement just a few things, and then you take and you implement a few more things, and you keep doing that. And so you increment and build upon what you've already done. The other thing is you get user feedback. So the focus of this agile development is to get a minimum viable product and get it to your users and get them to start using and get that feedback back, which then feeds you back what you need to do. So you get what type of requirements or what they're looking for. The agile development is kind of not really as formal. It's more about getting what does the customer really, really want and doing that. And so that's kind of what the advantage of agile right there is you get instant feedback from the customer, from what they want. And it also means that you can do quick deliveries to them. You can make these small little changes, see what they want. Do they like this? Yes. And you can make the change. That means you can also change the product. So for example, if somebody comes in and says, I want this product to do A, and you start to slowly implement A, and they say, you know what, I really don't like A, it needs to do B. You can pivot right away and switch over to that B using Agile. Maintenance, testing, and integration are smaller efforts with each iteration. So it's not as big of a production to be able to do each of these. You're building off of each other. So it's not only just the design and implementation of your software, but the testing and integration as well. It's very adaptable. And when done correctly, I feel like this is best for products that really need to change quickly. Web apps is a really good type of system for this. When you start doing and playing around with web apps and you see your users really don't like this type of feature, you can immediately pivot and change the behavior of your software to do that. There are some disadvantages to agile development. I feel like it's more prone to requirements creep. So when you're presenting something in front of your users, they oftentimes think they want something, and they start adding more things to it, and even more things to it, and even more things to it. Sometimes that's a good thing. Sometimes it keeps you in business. Other times it prevents you from ever really realizing a full product. And that's kind of the big problem there is realizing a fully finished product may actually never occur. You're constantly working on this tool and it never ends up that way. It never reaches its full developmental potential. And sometimes that's a good thing. Again, web apps, they need to be able to pivot. They need to be able to change. And that's exactly what you want to do. Spacecraft, once they launch, we can't reiterate on the things that we do. It is what it is. And you don't really want to be making massive changes or pivots to your software unless you absolutely have to. And so that's kind of a disadvantage there for that. So in summary, and from based off of my experience, I've worked for a subcontractor. I've worked for NASA now. I've worked under the DoD. Most software developments that I've seen kind of falls somewhere in the middle of waterfall and agile. And it's kind of interesting that works. A lot of companies try to implement and say we're doing agile, but in reality, it's an agile within a waterfall process. And I've also seen that in the same thing where it's a waterfall process, but they're kind of waterfalling over and over and over again, and almost becomes like an agile really process. To be honest, there really is no secret weapon out there. There is no process that is better than another. It really depends on what type of requirements you have, on what type of constraints that you have in development. And finally, also what the people that you're working with are willing to do. Maybe you have a lot of developers that have been in the industry for a long time and they don't want to make changes and they want to keep it the way that they've been doing it, whether that's the waterfall or the agile method. Sometimes you just kind of have to deal with what other people are willing to do. Either way, it is important to nail down a process for developing your software. As a beginner, you probably don't need to worry about this as you're doing a single projects. But as you start doing these more complicated and bigger projects and start joining maybe an open source project or these other things, it might be important to understand and realize how these processes work and become more and more familiar with them. So next up, what we're going to learn about is how to write your first Python script. So let's get into this. Let's do this and learn how to do our first Python script. I'm really excited for you. So let's do that.